Good afternoon, ladies and gentlemen, and welcome to this webinar on the future of smart metering enabled by low-power wide area wireless technology. Before I begin, I'd like to mention that questions for our speaker can be directed to him via the question and answer box on the left-hand side of your screen. Additionally, the webinar will be available on demand tomorrow morning, and we will send you a direct link to the audio and presentation file. Our webinar today is brought to you by Telit, a global leader in IoT enablement, which provides enterprise-grade hardware, connectivity, and platforms which transform businesses through the power of IoT. Now, today we're going to be providing an overview of the different low-power technologies in the marketplace and which of these technologies is best suited for various metering applications based on location, data rates, power consumption, latency, or even the level of security. And our speaker this afternoon is Marco Argenton, who is the Product Marketing Manager at Telit. Now, Marco manages the product portfolio for Telit's cellular IoT solutions portfolio, and in his current role, he's mandated to identify new business opportunities and to ensure the company's commercialization of the cellular module portfolio is aligned with corporate objectives and profitability. He holds a degree in telecommunications electronic engineering from the University of Trieste and has completed postgraduate courses in the Child Business School in the area of innovation and R&D. Marco, without further ado, I'm going to hand over to you. Thanks so much.
Thank you very much, Claire. Hello, everybody. And let's get this webinar started. So, as you have heard from the introduction, I will try to give you an overview about the different LPWA technologies in the marketplace, with a particular reference to the metering market. As you may know already, there are several technologies, and depending on different aspects and features, some of them could be more suitable than the others, and the main aspects, in particular when we are talking about metering, are features like data rates, power consumption, latency, security, and so on. As Claire said, Telit is not a metering company, of course. We are an enabler of IoT solutions, and metering is one of the verticals in which we can probably say to have a deeper understanding of customer needs. And we also have an important presence in the market, with several millions of devices deployed in the field worldwide, but in particular in Europe. So based on this background of information, I will try to guide you through this webinar. Let's start then with some considerations that are driving the cellular IoT. And every application has, as I said before, different needs that require various considerations, such as coverage, power consumption, security, scalability, interoperability also. And these factors determine the choice of the proper IoT technology. And we could, in a way, identify and group these aspects into three major categories: technical, commercial, and ecosystem related, which helps to provide a structured approach to the analysis of the requirements. And the defining characteristics of an LPWA network are to support devices that are low power, both in terms of processing and transmission power. That is a common expectation, for example, of a battery life of more than 10 years. There is the objective to reach a cheaper, always cheaper, and low-cost device, to provide extended coverage at the edge of a cell inside of a building or in the basement of a building, for example. And these technologies have the target to be perfectly suitable for IoT applications that only need to transmit tiny amounts of data in a long range. This slide actually is titled Cellular IoT, but as we will see later on in this presentation, there are also other unlicensed spectrum technologies that are addressing some of the same requirements and needs. And another interesting and potential evolution, for example, in the LTE IoT space, is the usage of the unlicensed spectrum also for technologies that today are licensed. For example, there are already alliances and working groups that are actively adopting LTE IoT to operate not only in support of mobile broadband and high-performance applications, but also to bring new opportunities for private LTE networks and to enable LPWA use cases, leveraging both the eMTC and narrowband IoT technologies in 3GPP release 13, for example, and beyond. But we will see this in more details in the next slides. This was a general introduction to the concept of cellular IoT. But let's see why metering is the perfect use case for this discussion. First of all, metering is a market driven by factors such as government policies and mandates in developed economies and accurate billing and improved customer service. Then there are other drivers such as consumer awareness, network resilience, as I said before, the need for a better coverage for poor reachability and applications with limited number of data, long lifespan of devices. Other drivers that are becoming more and more important are, for example, the target to reduce energy theft or the upcoming volumes of electrical vehicles, for example. So you understand from this short list that has not the ambition of being fully comprehensive of all the possible requirements of this vertical segment, but just from this short introduction, you understand how all these technologies in the IoT space are relevant in order to achieve the final target. Moreover, the industry is evolving, so there are new aspects such as gas safety or water efficiency, or also the customer expectations that are changing. So the customers, the end customers of our customer, so the end user at home, are looking for additional services. And in order to get these additional services, we have to invest and implement new technologies that are also, by the way, enabling new business models. And the proof, in a way, that metering is the perfect use case is given by this demo that we did already more than 1 year ago with, in that specific case, narrowband IoT technology. And I can tell you that Telit was not the only one to do that. All the new players approaching to these new technologies have decided to take metering as an example, because as we said before, it is really fitting all the major aspects and features of the new technologies. In that demo, we demonstrated narrowband IoT with one of our modules embedded into a meter, a gas meter of one of our customers, and we managed to get the communication through the LTE network to the cloud application of our customer, enabled by our tools. And the importance of this end-to-end was not just for the technology itself, but also, as I said at the beginning, because Telit is not only an enabler of the technology by means of the device that you can see on the left, so a module implementing the technology, but also Telit has the ability to provide and to support the customers through all the value chain with also connectivity and cloud services as well. And in particular, if you have a look at our website or the recent news about the company, we recently announced, for example, SimWise, that is a disruptive solution, very innovative, that for the future market has the target of removing the physical SIM card that often for new enabler of cellular technology is a barrier to entry. And the ultimate purpose of this is to reduce the total cost of ownership of the solution, and also, why not, to reduce the size that is required for implementing and embedding the technology. So we discussed about narrowband IoT, the first demo that we did in this vertical segment, but we don't have to be distracted by the buzzword. Probably narrowband IoT is the most common and trending topic in the last 12 months. But the question that I put in this title is this technology really the technology for this vertical? Because apparently, if we look at the requirements of this market, in deep indoor coverage, low battery usage, low-cost devices, low throughput, small size, secure and scalable, strong ecosystem, solid alternative to current GSM, and cost-effective solution. Well, on the paper, we could say, wow, if I compare these requirements to the features of the technology, there would be a one-to-one match. But the reality is that, yes, it is one of the possibilities, but not the only LPWA technology, and not always the most suitable. In the previous slide, when I talked about the demo we did last year, if you noticed, it was a gas meter, and I will have the opportunity in the next slides to tell you which are the differences between different applications. Why gas meter or water meter, for example, instead of electricity meter? Let's do a step back. So, again, from a general perspective, LPWA at a glance, without a specific focus on metering, but just to have a look at the technology. I told you that there are not only cellular technologies, but there are also unlicensed spectrum technology. And in this table, there is a summary of, I would say, the most common in the market, at least nowadays, that are LTE Cat M1 or MTC, LTE Cat NB-1, or known as also narrowband IoT, LoRa, or Sigfox. And of course, there are differences that you can read on your own in terms of spectrum, frequency band, different speed in uplink or downlink, mobility, that of course is not the case for metering because a meter is not moving, but in general, for example, LTE M1 is more suitable for mobility while the others are not. The cost of the solution can change also because the unlicensed spectrum as of today have an advantage being early to market, so a better economy of scale, but the cellular solutions will catch up soon, and the vendor ecosystem that could be different from one to the other. But the purpose of this slide is to say that there are some overlaps and some peculiar characteristics that differentiate one from the other. But in a way, this variety of standards is causing the wireless standards to blur in a way. So as you can see from the chart on the left, depending in which direction you're moving, you can obtain your perfect fit depending on what you're looking for. And I also would like to tell you that this table is just a summary, as I said, of the most known technology, but it is not comprehensive of all the possibilities. There are other standards out there in the market that have been used and that will be used in the future as well. Just to mention some of them, weightless or YSAN or WirePass are all alternatives depending on the region in which you are going to deploy, on the requirements that you need to fulfill. If I have to do a simplistic summary for the cellular technologies, I could say that, for example, LTE-M is most suitable for electricity, for example, while narrowband better for gas and water. But this is not true and valid in general. It is really depending on the country and on the requirements of the installation. And also a distinction between proprietary standard for local and private networks is an option and a possible solution. When I said at the beginning that this is a regulated market and this is one of the drivers for the adoption of the technology, I would like to mention this again because often we say there is not one technology that fits for a specific use case, but when we say this, we refer to the application. So different applications are having different requirements and different needs. In the case of metering, it could be that the same application, the same smart meter, with the same physical characteristics, let's say, has different requirements depending in which country is going to be deployed, because it could be affected by different regulations, different architecture and infrastructure in which it is deployed. So this is the reason for which we must keep in mind that there are different possibilities. And again, in general, if we look at LPWA, we have to say that at the beginning of the story of low power wide area, actually there was not a big traction. So a long history, but a minimal growth at the beginning. Then there was a market inflection in the, I would say, last 5 years. Mainly, and in particular in the last 2 years, mainly because of the most common unlicensed spectrum technologies like Sigfox and LoRa, and this caused the 3GPP reaction that accelerated the standardization of, for example, the release 13 with Cat-M1 and narrowband IoT. And this is now creating a big momentum in the market, and we will see finally the volumes to ramp up with an eventual incorporation into 5G. But this is something that I will explain better in detail at the end of this presentation. So if this is the situation in general, and I said long history, but with a minimal growth at the beginning, I have also to specify better that this is not really the case for metering, because metering has been, the metering industry has been a pioneer in the connected world. And even if we were not talking about LPWA, that is a quite recent acronym for the most recent technologies, we can notice how in the market there are, since 10 years or more, already deployed in the field solutions that are connected. Maybe at the beginning it was simple GSM, or recently 3G or LTE, but still an industry, in particular for the energy segment, that is really expert in communication in general. And if we look at the scenario in Western Europe, smart metering has reached an early stage of maturity. According to a research by Berg, for example, almost 40% of the more or less 280 million electricity customers in Europe, by the end of this year will have at home a smart meter. And this is a share that is set to increase to 70% over the coming 5 years. The forecast is about 28 million units shipped per year around 2019, 2020. It is so mature in terms of expertise in communication that there are early adopters that are already preparing their second wave. And why this is happening? Because the solutions deployed in the early 2000s are becoming outdated in terms of functionality and performance. The lifespan of a meter could be estimated around 10, 15 years. So you understand how now is already time to replace the solutions in the market. Moreover, we can also see a gradual shift from PLC technology, power line communication, towards wireless technologies or hybrid technologies, a mix of RF and PLC. I say gradual shift because in reality also PLC is a valid technology in some cases and will be deployed also in the future, and I will show you the trend. But just to give you the full picture of how this industry is evolving. And of course, recently the massive investments on IoT has generated a large amount of wireless standards, as we discussed already till now, and a plethora of different wireless standards. So let's see which is a possible trend. This is an analysis that I have taken from ABI instead, that is showing the shipment forecast in the world market for smart meters in millions of pieces on the left-hand side of the slide, and the installed base by technology on the right-hand side. What is important, independently from the accuracy of the figures, you can read the different market analysis and find slightly different numbers, but the message behind this is much more important for me to tell you right now. And as you can see in the left chart, the electricity metering industry in terms of shipments of new devices is going to reach a peak. Why this? Because we have just discussed about the maturity in the market and the second wave. So now, once we arrive to the saturation of the market in a way, the new shipments are not new installation, but are replacement of existing installations. On the other side, instead, it is very interesting to notice how the emerging technologies are affecting the ramp-up of, for example, gas and water metering, that with legacy technologies were not suitable for deployments because, for example, the consumption was not good for battery-powered applications. And now, with the new trend, instead, they are able to be connected and to be deployed in the field. If we enter into a discussion of technological trends and not market trends instead, as I said, at the beginning it was GSM that is still by far the largest market share in terms of devices deployed in the field. 3G may be smaller quantities, but there are a few important tenders, for example, that are ramping up. And recently, 4G. 4G, if we look at, for example, US, Korea, or Japan, but also in Europe in some cases, there was a first move to Cat 1, and in the countries where 2G and 3G has been already announced to be shut down, as in US, for example, has been the first alternative. Okay, but there was not even the time to adopt Cat 1 in a massive way that we are in front of the push towards the new standard, Cat M1 and narrowband IoT once again. But then we have to discuss if it is a matter of use case or price, if it is a matter of adopting a technology now or waiting for a better solution in the future. Definitely in US there was a quick move for Cat M1 because this was the major choice by AT&T and Verizon, if we talk about operators, for example. And some delays on important EU tenders are in a way in favor of this adoption of the latest technologies, because there is no need anymore to deploy the previous technology, but the last one can be adopted. By the way, as I am listing on the right-hand side of this slide, cellular, and as I said before, is not the only possibility. We don't have to be focused only on cellular. There are a lot of examples of cellular plus wireless and bus, for example, in the case of a hub for grid electricity and gas. Or if we look at the North American market, there is a strong presence of solutions that are RF and wireless mesh, not cellular. In the Far East and also in our region in Europe, we are noticing an increasing interest for LoRa technologies, both for public and private networks. And as I said before, there are other LPWA standards that are relevant for some local deployments, and sometimes these local deployments are really relevant also in terms of number of units deployed in the field. So if we go a step back into the market trends, as I said, there are some markets, some regions in which the move away from legacy technologies like 2G and 3G has been forced by the choice of the operators. If we look at the adoption rate of licensed LPWA, narrowband IoT and Cat-M1 are those with the highest forecast and CAGR for the next 5 years. And in general, not in the metering industry, but in general. And if we look at the metering applications, we don't have to think only about the smart meter itself. There are a lot of applications around the metering industry, both for residential and industrial and commercial applications, and a lot of sensors, for example, to monitor the overall infrastructure. It is not just the meter itself reading the measurement and sending data to the end user or to the utility, but there are also a lot of other possibilities that are enabled by the new solutions. So with the new technologies, we can achieve a lower cost. They have a limited speed, but very often this is more than enough for this kind of applications, and a better coverage. And then there is the discussion about the upcoming 5G. Well, LPWA is now, and there is no conflict with the upcoming 5G. And I have the possibility to tell you more in a second about that. So if you have the need to adopt one of these new technologies because you are in front of a phase out of the legacy network in the country in which you are deploying, you don't have to be scared about trashing the job that you do today in 5 years from now, when there will be the need to move to 5G, because there will be a smooth evolution, and I will tell you how. Of course, LPWA market is growing quickly, and just as a matter of fact, China is a key factor. All the exponential growth that you can see in all the charts of forecasts for the future are highly driven by a lot of deployments that I can tell you are already happening in this country, and mainly because of metering. So once again, the perfect use case that I tell you at the beginning is again relevant because it is creating the first real massive deployment of those new technologies. So if we have to decide which technology to adopt, we are in front of a technology trade-off. And we have to understand exactly which are the features and which are the requirements of our application, of our deployment. The vision that I can give you based on our experience in the market is that the narrowband IoT, for example, is good for basic usage and rare communication. Basic usage, I mean simple readings, limited throughput, and transmission, not every hour, but maybe once per day. This is a perfect scenario. Cat-M1 is, for example, perfect, in my opinion, for throughput and latency. And if I have an electricity meter that is installed in a complex architecture And the requirement in terms of payload is not so small, and I have to transmit a relevant amount of data, not just a few kilobits per second, but some hundreds. Maybe I cannot do it with narrowband IoT. It's better that I use Cat-M1. I don't have a problem of power consumption if the device is installed in an electricity meter. The consumption of Cat-M1 is much better than the previous LTE technology, but still, being in an electricity meter, I can also transmit every minute because I don't have problem of running out of batteries. The current 3GPP release 13 technologies are probably not yet ideal for a long battery life devices if they are frequently transmitting. But also in this case, I cannot give you a final statement. If a device is waking up and transmitting once per day, it is good. If your device has to wake up and transmit every 10 minutes, probably this is not the right technology for you. And then there are other aspects that you probably have to take into account. We are talking about security, we are talking about firmware over-the-air upgrade, if you have the need or not to have a private network. And as we said, the upcoming 5G, what to do, what is coming. So let's have a look at what is coming with this slide, in which I summarize the major features and the major standards in 3GPP that are bringing to the evolution to 5G. So I said several times already that, for example, Cat-M1 and narrowband IoT are technologies that have been defined for the first time with the release 13. Most of you might know that there are improvements coming with release 14 that in fact is addressing a feature-enhanced MTC, that is the evolution of M1, and an extended narrowband IoT, that is the evolution of NB1, that will be called NB2. And from release 15 and 16 and beyond, there will be the definition of 5G. But you have to keep in mind that we are not talking about two different things. If you think about 5G, often you think about high-speed communication. This is not the only use case. Yes, it is the first that you will see starting from 2019, 2020, and it is definitely the first use case, in particular for mobile phones. But there is a parallel activity of standardization in order to bring the current technologies to evolve and be merged into this big umbrella that is 5G, in order to fulfill the needs of the so-called 5G IoT. Because there is not only the need of massive broadband, but also the need of massive IoT. A lot of devices in the field, high density in urban scenarios, for example, and additional features that I will mention in a second, like low latency or reliable communications. Sorry. So one of the buzzwords or the keywords in metering is the concept of smart grids, and we just talked about transition to 5G. So why this is important, and which could be the impact on this scenario? Well, first of all, we have to say that the deregulation of the energy market has as a consequence an increased exchange of large amounts of power between adjacent areas, potentially under the control of different utilities, by the way, and also an increased penetration of renewable energy sources as a consequence of larger system dynamics due to the intermittency of renewable sources. So this scenario is bringing to the concept of stability, the need for stability, the need for mission-critical and real-time applications in order to monitor, read what is happening in real time, and execute and take the control. So the need for timely and accurate monitoring of the smart grid. And this is why all the technologies that we mentioned so far are complementary one each other, and the massive MTC, the MMTC, will be the backbone, in a way, of this infrastructure, allowing the deployment of a large number of simple devices, simple sensors. Sorry. And on the other side, the keywords are low latency and high reliability. These are technical aspects that have been defined and identified, and they are going to be standardized with the next 3GPP releases according to the roadmap that I just presented. And altogether, they will contribute to the improvement of the smart grid scenario. That, for this reason, 5G at the end is the ideal arena for the future distributed smart grid services. So, if this is the overall scenario of LPWA in the metering industry, please allow me to tell you something about some Telit solutions that are available to enable your products with the latest technologies. So I have a couple of slides related to Telit portfolio. This is related to the cellular portfolio that is divided into different form factors, depending if you already have a design with 2G or 3G or 4G that, for example, is based on 910 form factor. You will find also the possibilities according to the region or for global solutions to have your own module to support Cat-M1 or Narrowband IoT or both, solutions that are single mode or featuring the fallback to 2G, because of course we have also to analyze where you are going to deploy. As I said before, if you are in a country where 4G network is already at 95% of the population, you can go with an LTE only solution. If the coverage is not good, you might need a fallback to a legacy technology just to be on the safe side for the future. But as you can see from the variety of the application with this family, you have definitely all the possibilities to deploy your devices worldwide. If instead we go on the other extreme of our portfolio, the 866 family is the smallest, so less variance, regional, but with a very high level of how can I say, integration of the technology into such a small footprint. And once again, we have solutions for Cat-M1 and we have solution for Narrowband IoT. Last but not least, still in the cellular portfolio, the L865 family, because this is our bestseller in 2G and, by the way, in the metering industry as well. So in order to allow a migration path to the new technologies, we have decided to put in roadmap both the NL865 and the ML865 in order to give a future-proof solution to our customers. If I presented the cellular portfolio, there is also the alternative non-cellular portfolio. In our offering, you can find solutions based on LoRa, on Sigfox, proprietary solutions sub-gigahertz, and wireless and bus. If you remember, I mentioned before how the combination, for example, of wireless and bus and cellular is definitely something important in this segment. And for all the situations in which you are not comfortable with a cellular technology, with us, you have also the opportunity of deploying something different, but still in the LPWA area. Let me finish this presentation with a last quote that I have taken from Ernst & Young. Smart energy meters provide gateway to the home. no ambition now to initiate a very long discussion about privacy of your data, security, and all the related aspects that would require not only a webinar, but some hours of discussion, but just to put on the table a topic that would be or could be worth discussing, because it's not just a matter of sending technical information across a smart grid, but once all these devices will be connected to each other, there will be a backbone, there will be a communication channel entering in your house, and this aspect has a lot of implications, and it is not by case that before I put also security into the requirements and possible drivers of the decisions and solutions in the future. So I think that I have been pretty much respecting the timing for the presentation, so at least we have some time for Q&A. I hand it over to Claire for a second.
Marco, thank you very much. Well, ladies and gentlemen, we have quite a number of questions to go through. And just to answer one of the questions that has been coming up time and time again, the audio and presentation will be available tomorrow. We will send you a link to that. And yeah, so please just look out for the email from our officers. Marco, I'm going to just start with the first question, if you don't mind.
Yes.
And that is, how ready is the industry for GDPR? And that's from Seb.
Just a second. Can you repeat, sorry, the question?
Sure. It's how ready is the industry for GDPR? It's question number 4.
I'm not sure I understand exactly the question, so I would prefer to take it offline and answer later on to this one, if you don't mind.
Okay, fine, Seb. Marco will get hold of you directly. The next question is, end-to-end SIMs obviously have a longer anticipated life than standard SIMs. What do you anticipate the life of onboard SIMs to be?
Well, I guess the question is related to and not only M2M in general as a ruggedized solution for the standard SIM, but in particular for the EU ICC and embedded SIM. So I would say that every time we go for a solution to be embedded into a meter that, as I said, has a lifespan of 10 years, for example, this is also a requirement that must be matched by all the components and the SIM itself. I don't see any particular issue for this kind of solutions currently available in the market. The additional comment that I could say on this is that, as I mentioned at the beginning of the presentation, Telit is working on an alternative concept, an alternative solution that, and I can take the discussion offline, of course, if someone is interested, that will remove even the problem of that this question is putting on the table, because I do realize that it is a critical element in the definition of the architecture. So if we can have an alternative proposal, this would be even better for customers to be adopted in the future.
Okay, listen, I hope that answers your question. A question from Joseph. He says, you list NB-IoT as a sub-gigahertz radio. There has never been deployments over 1 gigahertz. Does that have to do with any technical features in particular?
This is question number, so that I can have a look.
Number 8.
Okay. Yes. There are implementation above 1 gigahertz. The most common are definitely the sub-gigahertz for a simple reason: better coverage and better indoor building penetration. But sometimes it's also a matter of the spectrum available by the different MNOs. So I can tell you that if we talk about narrowband IoT, as in the case of this question, band 8, band 20, so 800, 900 megahertz are the most common. But there are, for example, roadmaps and deployments in Japan, the first one that I remember, where, for example, 2100 is considered. So definitely above gigahertz, and in this case, most likely it is because the operator has this frequency and is going to adopt the same base stations to be upgraded for the recent technologies. And if in urban scenario with high density, probably they can reach the same level of performance also with a higher frequency. So everything is possible. In particular, with our MIN-10 devices, we are able to support multiple frequencies, not only sub-gigahertz, in order to allow deployment in different countries and in different MNOs networks.
Okay, thank you very much. Joseph, I hope that answers your question. Ladies and gentlemen, just excuse us for 2 seconds while we identify the next question. There are a number of them, and we're trying to make sure that we cover as many of the questions and as wide a spectrum of these questions as what we possibly can. So please just bear with us while we quickly try and work through them. Right, so our next question is from Edward, and he wants to know, or he says, AMI networks have served smart metering applications for the past several years. A couple of the challenges that these networks have addressed over time are the ability to perform over-the-air firmware downloads to thousands, or in some cases millions of devices. What is the ability of LPWA devices to successfully enable over-the-air firmware downloads in a network of 500,000 devices or higher?
This is a good question, and in fact, I also put firmware over-the-air upgrade as one of the features that in the technology trade-off in order to be evaluated and considered before taking the final decision for the next generation of products. And definitely, I have to admit that this is a challenge. Our devices are already supporting the ability of firmware over-the-air upgrade across all the different technologies. One of the first limitations that everybody realized once approaching to the new LPWA in cellular networks was the limited throughput. So for a battery-powered device, a limited throughput is reflected into a long time to upgrade the device, and therefore the risk of running out of batteries faster if the module must stay in operation mode for a long time. But there is also to say that all the LPWA devices have a limited footprint. So the optimization in terms of cost, speed, etc., is not for free. I mean, there has been a lot of investment by the silicon vendors to squeeze their chipset and to also to squeeze the protocol stack in order to fit in a much smaller memory footprint. So yes, it is true that the throughput is limited, but it is also true that the amount of data to transfer is much limited than an LTE Cat4 device, for example. With regards to the ability to upgrade network with 500K devices, this is something that is being addressed as well in the 3GPP working groups. And if you look at the improvements, for example, of Release 14, there are aspects in a way going in this direction, introducing multicast, for example, and more in general, the ability for high density scenario for tons of devices to coexist. So it will take time for having all these new aspects in place with the maturity that each release of the standard will have to reach. But I see a solution for each of these scenarios. So I would not be worried about because I see a very high awareness in all the players in the ecosystem and ability to upgrade, and not only to upgrade the modules, but ability to do device management is typically one of the first questions in the RFQs or RFPs. So there is definitely an awareness and an understanding that this is a key aspect that must be addressed together with all the other challenges that I mentioned during this webinar.
Okay, thank you. Edward, I hope that has answered your question. I have proposed a couple of more questions to Marco. We have about 8 minutes before we are going to have to wrap up this webinar, and I know that there are a number of questions that we are not going to get through to today. But there will be somebody from Telit who will get hold of you. Each one of your questions will be answered. And for those of you that are requesting contact details for Marco, we will pass all of these questions on, and then somebody will get hold of you so that you can continue the conversation. So our next question is from Ruben, and he wants to know, is ME910C1WW available yet, and when will it be available?
Okay. So this is a specific question about Telit portfolio. Thank you for that. Just for those that are not aware, ME910C1WW is the name of the device that we have given to the global product. So a device that is able to support both Cat-M1 and narrowband IoT with the possibility of fallback to 2G. And the fact of the ability to support several bands, as I said before, not only the sub-gigahertz, but a lot of different frequencies, is giving the ability to be deployed in several countries. We are going to have samples right now, and starting also the certification process. So by the end of the year, this product should be all set for the first ramp up of deployments, or in case for customers adoption and starting their design. We all know how the designs in the metering industry require a longer time because of a lot of other regulated aspects, not only for the module but for the application itself. But it is really coming soon.
Okay. Sorry, ladies and gentlemen, I do apologize. I've lost my place here a little bit. Ruben, sorry for that. I hope that answers your question. Our next question is from Peda, who wants to know, what do you think the split will be between cellular and non-cellular for water or gas metering?
Okay. This question gives me the opportunity to spend few words on the chart that I presented in the middle of the webinar. I spent more time on the one on the left, but I didn't say anything on the one on the right. So, in that slide, if you have the chance to see again the recording of this webinar, there is a forecast of growth of the different technologies, PLC, RF, non-cellular, and cellular. And the interesting part is that the growth and the installed base numbers of the non-cellular is higher than the cellular. This is, of course, according to this market analysis, but I'm not really surprised because there are a lot of different standards in the non-cellular space, and most of them are suitable for battery-powered application. So now I don't have, let's say, the crystal ball to say which will be the split in percentage, but definitely they are going to play both cellular and non-cellular a key role for gas and water, with a possible advantage for the non-cellular, in particular in the short term, because there is an advantage, as I said also before, of being early to market, while the new 3GPP releases in some cases are probably not yet perfectly suitable and are requiring some improvements that are coming with the new release 14 and beyond. So if someone will decide for a more prudent approach, waiting for the improvement on the battery consumption, for example, they could go instead for an alternative, and this could justify the increased numbers on non-cellular deployments, at least in the next couple of years. Then, in the long run, my feeling is that cellular technology will close the gap and could be even higher because of a lot of other reasons: scalability, availability at global level, security, quality of service in general. So if we look at all these aspects, in the long run, probably the cellular technologies could have an advantage, but in the short term, these non-cellular standards for those applications, gas and water, could be a good choice.
Right. Ladies and gentlemen, I think we have time for one last question before we need to wrap up. Marco, do you want to? Okay, I see you've identified the question that you'd like to speak about. So this one is from Andre, and he says, are Cat NB1 based devices going to be UDP only from application level networking perspectives? And what about the Cat M1 modules?
This is I selected this question because this is a recurrent topic, and often there is, in my opinion at least, but I might be wrong, a misunderstanding in matching the support of a technology or of a protocol like UDP in this case, associated with the technology itself or with the module or with the network. In general, narrowband IoT is for sure a technology that is more suitable for UDP rather than TCP, because of all the reasons that we mentioned so far. Reduced complexity, lower throughput, lower computational power. So at the end, a simpler transmission of UDP packets is definitely more suitable, but then it depends on the platform. We have, for example, a device that is supporting only UDP, because this is a limitation of the platform, not our decision. We have another one where you can have an embedded TCP IP in the module itself, because the processing side is more powerful, and then it will depend on how you manage the application. It is not forbidden by the standard to use one protocol or the other. So we have to discriminate between the technical possibilities and what the standard is about. But yes, more in general, let's say that UDP and narrowband IoT is a marriage that will often take place, while for maybe Cat M1 devices, as it is in the question, we can see the old approach of having the full stack TCP supported.
Okay. Andrea, I hope that answered your question. Ladies and gentlemen, we are unfortunately out of time. And Marco, I wanted to say thank you so much to you specifically for your time and effort, and for putting together a truly amazing presentation. We've had so many questions that have come in today. And as I said, ladies and gentlemen, I know that you have not all received answers to your questions, but somebody will be in touch and follow up with you. So Marco, to you, thank you so much.
It's me to thank you for hosting this webinar, and I'm also sorry for not being able to answer right now to all the questions, but I'm saving the recording right now, and I promise that I will follow up with the questions for everybody. And thank you to the audience that for 1 hour stayed with us listening to this webinar.
So, ladies and gentlemen, from us at Metering and Smart Energy International, and on behalf of Telit, we'd like to say thank you for your time this afternoon. Please look out for the email from us tomorrow with the links to the audio and the presentation. And I wish you a wonderful day further. Thank you very much.